So hello guys, this is class 2 of game theory. Class 2 game theory. And in the previous class we discussed about dominant strategy and I gave you some brief introduction of the basic elements of game, which was player, strategy and payoff. Okay, and I also told you some uh, outline that how do we solve a question, and I told you the shortcuts also, which was the underline method to calculate the Nash equilibrium. Also I told you in the theory also that how you have to calculate Nash equilibrium while writing the statement. Okay, so now in this chapter, in this class, we will start this class by prisoner's dilemma. Or you must, if you haven't seen the Beautiful Mind yet, you should today only you watch this movie. It's a great movie, and it was based on the it was based on the economist John Nash, who actually gave the Nash equilibrium. Okay, so in 1950, John Nash proposed a new tool for thinking about the strategic decision, that is Nash equilibrium. Okay, so as I already told you that in Nash equilibrium, each player is doing its best given the action of its opponent. Okay guys, so in simple words, it means that each player anticipate that what its opponent will do and then decide to choose the best possible action. I already told you this and again I am repeating. Okay, so what does Nash equilibrium do? It actually results in the stability in the strategy. This is because that once Nash equilibrium has been attained, there is no incentive for any player to deviate from his Nash strategy, because if he deviates from his Nash strategy, then he won't be considered as a rational player. Okay, so each player is contented with his choice of strategy and no player want to play anything different than Nash equilibrium. Okay, so this Nash equilibrium can also be explained through self-enforcing agreement. So what is self-enforcing agreement now? So in self-enforcing agreement, each player has an incentive to abide, or we can say restrict, by the agreement on the assumption that other players shall continue to abide by the agreement. So what does it mean? That it is an agreement that is enforced only by the parties to it. That is, no external party can enforce or interfere with this agreement. The agreement will stand so long as the party belief is it's mutually beneficial and it is not breached by any other party. So this is only what Nash equilibrium tells about. Okay, then it tells about that as long as it is beneficial for both, they won't the agreement will stand as long as it is beneficial for both. Okay, this in short tells this only, right? So now we will move further. So what is the problem with Nash equilibrium is that it does not lead to the Pareto efficient outcome, which I already told you in just short. What is Pareto efficient? That which is the most efficient outcome of the game. That is Pareto efficient outcome. So it does not, like, it is not the maximum efficient point on the game. Okay, so it may or may not be, but most of the time it is not Pareto efficient. Okay, so now we will discuss about the prisoner's dilemma. Okay, this is kind of interesting. So the prisoner's dilemma was given by A.W. Tucker. He was the economist. And in prisoner's dilemma, listen to me carefully. The participants are two suspects, that is A and B, let's say. Okay, so let's assume that there is a robbery in the bank. Okay, and after doing the robbery, the committee is set by the police committee is set to find the culprit, and they find out the suspect, They are not even they are not sure now, but they find out the suspect A and B. They find out two suspects. Okay, and what did they do is that they put both the suspect in different jail. Like, they are not interrogated in the same jail, they are interrogated simultaneously in the different jail, and each has been questioned separately. Okay, you got till here? And each player has two possible strategies. What are the strategies now? The strategies are that whether they can confess or they can do not confess. Only two things can happen in the interrogation, whether they will confess or whether they don't confess. So the authority needs confession in order to convict an individual. It's obvious. The authority must be needing an confession by the thief, that in order to convict. Without the confession he cannot convict anyone. Human right people will come in between, and they won't be in jail for the long time. Also, law won't allow them. Okay, so now listen to me carefully. So if only one prisoner confessed, then what will happen? Then he would go free, and the other player will be required to spend 6 months in prison. Okay, so if A confesses and B does not confesses, then A goes free and B gets 6 months of prison. Okay, if both players deny being involved, if both players do not confess, then what will happen? Then they both will be held for 1 month, and after that they will be free. Okay, they will only keep them for 1 month, because law won't allow them, because they haven't confessed. So they cannot be kept in jail for long. So they will be in jail for 1 month, and after that they will be free. And if both players confessed, then what will happen? Then both will be held for 3 months. Okay, so now if I have to make the payoff matrix of this game, so what will it be like? I have drawn you the first matrix of the first class. It is similar matrix, it is same matrix. Okay, so here it is B. B has two choice, whether he can confess or no confess. Similarly, A has two choice, whether he can confess or no confess. Okay, so this is the payoff matrix. It was given before that if they both will confess, how much will they get? The imprisonment. They will get imprisonment for 3 months. So I am writing it -3 -3. Since it is negative, the imprisonment is treated as a negative, so I have treated it as a negative sign here. Okay, so I have written it -3 -3. Now if I say if both will do not confess, so we have already tell you that they will keep for 1 month, after then they will leave them. And if one confesses and the other do not confesses, then the one who confesses will get 0 month, he will walk out freely, and other who did not confesses will get 6 month imprisonment. Similarly you can do from here. Okay, so this is the payoff matrix, and this looks similar. You must be familiar with this matrix, as this was the first matrix we used while explaining the game theory in first class. Okay, so if you see, if I all the basic of this, that solution will come this, and this will be a Nash equilibrium. But now what I will tell you, that this was all about the prisoner's dilemma. You can just write down now the everything we did earlier. I can show you also, because this is the same copy. So you can see this is the same payoff matrix. So you can show all this, you can show this, and you can write this much. So after till here prisoner's dilemma ends. Okay, so prisoner's dilemma ends now. Okay, so now if I tell you about some basic terms, that if row 1 is dominating row 2, what does it imply? It implies that the payoff of A in row 1 are better than all corresponding matrices in row 2. Right? Because if you see in this payoff matrix also, the rows are for A, the first one, the person who is here. For in this example, it is A. So if you see here, the rows are for A and the columns are for B. Okay guys, so if row 1 is dominating row 2, it means that all the payoffs of row 1 will be better than row 2. And you can also see that like -3 is better than -6, 0 is better than -1. You can also see this also. Okay, so this means that row 1 is dominating row 2. This is just an example. Okay, so thinking logically, it means that it is always better for A to confess as compared to not confess. What does it mean? It only means that it's always better for A to go for confess, because all the payoffs are better in confess than the no confess, since row 1 is better than row 2 and it's dominating. Okay guys, so it also means that it also implies that whatever player B does, player A will be always better off in confessing. Okay, so now we will talk about B. Okay, so now if we see of B, you can see that this column is good because -3 is better than -6 and 0 months are better than -1. 1 month is prison or free, 3 months is prison and 6 months is prison. So this is better. So you can see this column is better than this column, and column are meant for B because B is choosing this side. You can see from here also. You can choose either this or this. That's why we have called them column. Okay, so this means that column 1 is dominating column 2. It implies that all the payoff for B in column 1 are better than all corresponding entries in column 2, right? So column 1 dominating column 2 implies that whatever player A does, player B will be better off in confessing. Therefore, the unique Nash equilibrium for this game is to confess for both the players. So you can see your theory like this also. So it's best for both the players to confess. So confess is the Nash equilibrium. But as I already told you, it is not the optimal choice, because optimal choice is this one. If you see that this is better than this one, so it is obviously not the optimal choice. Okay, so that means it's not the Pareto efficient. So your theory of prisoner's dilemma ends here. Whichever I told you, like I told you from the statement also, and in theory also, you have to write both if you are asked prisoner's dilemma in exam, and then only your theory will end. You have to write all this like row 1 dominating row 2 and column 1 dominating column 2, like this. Okay, so now we will come on to the weakly dominated strategy. Okay, let's start from here only. Why to waste pages? Weakly dominated strategy. Okay guys, so what is weakly dominated strategy? Okay, so what we will do, that we will start with the example. I will show you with the example. Okay, so this is B, this is A. Okay, so if you write the payoff matrix, similarly I take here A1, A2, outcome for A, the strategy which A can play, the moves, and B can place P1 and P2, and the payoffs are 0 1 0 2 0 2 1 1. So if you see that for player A, all the entries of row A2, this is row A2, this is 1 1, yes, it's right. So all the entries of row A2 are at least as equal, you can see this is equal or greater than the corresponding entry. See, at least this is equal or greater than. If you see this, if you compare these two, it will be greater than, and if you compare these two, it will be equal. So it means that row A2 are all the entries of row A2 are at least equal to or greater than the corresponding entries of row A1. Okay, so what does it mean? It means that row A2 weakly dominates. Weakly dominates. You've also known also that this is the sign for weakly dominant. Okay, so it is like this only, greater than or equal to. This is equal to and this is greater than. So you can remember from this also. So this means that row A2 is weakly dominates row A1, or you can write row A1 is weakly dominated by row A2. Okay, so if player B plays B1, if player B plays B1, A can either play A1 or A2 because it is same. So A can play either A1 or A2, it's same only because the payoffs are same. But if B plays B2, B2, A will definitely play A2. Okay, as the payoff A2 is greater than the payoff of the A1. This reasoning provides a rational decision for player A to avoid the weakly dominated strategy A1. Okay guys, so it will be always beneficial for A to choose A2 irrespective of what B plays, since these are equal and it is greater than the above one. Okay, so this is known as weakly dominated strategy. Okay, so now we will see that what is the difference between the dominant strategy and Nash equilibrium. Difference between strategy and Nash equilibrium. Okay, so I make one matrix here. B1, B2, A1, A2, A, B. Okay, so this is your payoff matrix. So suppose there are two players A and B. A has two possible strategy A1 and A2, and B has two possible strategy B1 and B2. Okay, so now if you have to see what is the dominant strategy in this and what is the Nash equilibrium. Okay, so first of all, I'm telling about now dominant strategy. Listen to me very carefully. The dominant strategy would exist for A or for B or for both. Okay, it can exist, as we have seen in the previous games also, that dominant strategy can be for one player, can be from the other player also, or both player can also have the dominant strategy, as in this game. Okay, both have the dominant strategy. Also I have shown you other example also in which only one player has dominant strategy, and also the example in which no player has the dominant strategy. Okay, so for A, I am writing for A, dominant strategy. Dominant strategy for A, it means that A is doing his best irrespective of what B plays. Okay, so I am writing here only so that it will be visible if I turn the page, so you can't see this. So this is the dominant strategy for A. Similarly, you can write for B that A is doing his best irrespective of what B plays. But if you see about Nash now, so Nash, it will exist if the following is applicable for both A and B. There will be condition, and it should be applicable for both A and B, for A and B. So if we see from point of view of A, I'm taking A only from both point of view. So A is doing his best given what B is playing. So can you see the difference now? That here A is in dominant strategy, A is doing his best irrespective of B plays. That whatever B plays, he doesn't care, he's doing his best. But in the Nash equilibrium, A is doing his best and it is given what B is playing. Okay, so this is the basic difference. If difference come in exam, you have to write like this only. Okay, and the dominant strategy can be a special case for Nash equilibrium only. Okay, the dominant strategy is a special case of Nash equilibrium only. Okay guys, so this class will be only till here only, because the next topic is a big one, sequential games, and it has many parts, so I won't be starting it now. I will start it in next class. So in the next class we will talk about sequential game in which players move in sequence. Like I know that if there are two players A and B, so there is something like A moves first, then B moves. It will be like it will be in the sequence that they move. Okay, and there will be many games in sequential game also, like product choice problem, and there will be mixed strategy also. So we will do it in the from the next class. So this class is ended here only today. It was a short class. I hope you liked it, and tell me your queries in the comment box. Okay, so bye guys, study hard and you can do it. Okay guys, bye.